In this video, we're going to talk about how to integrate functions that turn into natural log functions. So let's start with this example. What is the antiderivative of 1 over x dx? It turns out that this is equal to the natural log of x plus c. The derivative of ln x is 1 over x. So the antiderivative of 1 over x is ln x. Now we need to put an absolute value around the x. You can't have a negative number inside a natural log function. So we need the absolute value there. Now let's try another problem. What is the antiderivative of 7 over x dx? What would you say? Well, we can move the constant to the front. And we know that the antiderivative of 1 over x dx is ln x. So the answer is going to be 7 ln x plus c. And so that's all you need to do for this example. Here's another example. What about the antiderivative of 1 over x plus 5 dx? What do you think we need to do for this problem? Well, this is equal to the natural log of x plus 5 plus c. Now you can prove it using u-substitution. So let's go ahead and do that. We're going to say u is equal to x plus 5, and so therefore du will be equal to dx. So in this problem, we can replace x plus 5 with the u variable, and we can replace dx with du. If the antiderivative of 1 over x is ln x, then the antiderivative of 1 over u is ln u plus c. Now all we need to do is replace the u variable with x plus 5. So the answer is going to be ln x plus 5 plus c. And let's use an absolute value symbol. Now how about this one? The antiderivative of 3 over x minus 4 dx. What is this equal to? It turns out this is going to be 3 times the natural log of x minus 4 plus c. So 1 over x minus 4 is ln x minus 4. And because you have the 3 on top, simply multiply that answer by 3. And you can use u-substitution to prove it. Here's another one that we could try. What's the antiderivative of 8 over 5 minus 2x dx? So we're going to have a constant 8 times the natural log of the stuff in the bottom, 5 minus 2x plus c. Now, the derivative of the inside, the derivative of 5 minus 2x is negative 2. So we're going to have to divide it by negative 2. So the answer is going to be 8 over negative 2, which is negative 4, ln 5 minus 2x plus c. Now feel free to pause the video and use u-substitution to prove that this is the answer. Go ahead and try it. So we're going to make u equal to 5 minus 2x. So therefore du is the derivative of 5 minus 2x, which is negative 2, times dx. Now solving for dx, it's du over negative 2. So we're going to keep the 8. We're going to replace 5 minus 2x with the u variable, and dx, we're going to replace it with du divided by negative 2. So 8 divided by negative 2 is negative 4, which we'll put to the front. And the integration of 1 over u du is ln u. So we have negative 4 ln u plus c. Now all we need to do is replace u with 5 minus 2x. So it's negative 4 ln 5 minus 2x plus c. And so that's it. This is the answer. Let's work on some more examples. What is the antiderivative of x divided by x squared minus 3? So what can we do in this problem? So here we could use u-substitution again. Let's make u equal to x squared minus 3. Now the reason why we want to do that is because du is going to be 2x dx, which can cancel with the x on top. So now let's solve for dx. dx is equal to du divided by 2x. So now let's keep x. Let's replace u squared minus 3 with x squared minus 3 with u. And let's replace dx with du over 2x. So let's cancel the x variable, and let's take the 2 and move it to the front. So when we move it to the front, it's going to be 1/2 integration 1 over u du. The antiderivative of 1 over u is natural log u plus c, and times 1/2. So now let's replace u with x squared minus 3. So it's going to be 1/2 ln x squared minus 3. Now we need the absolute value because x squared minus 3 can be negative. Let's say if x is 1, 1 squared minus 3 is a negative number. And so here's the answer. It's 1/2 ln x squared minus 3 plus c. Here's another one for you. What is the antiderivative of x squared minus 4 divided by x dx? So here we have a fraction like before, but this time we only have one term in a denominator. In this case, what you want to do is divide x squared and negative 4 by x. So you want to break the fraction into two smaller fractions. X squared divided by x is simply x, and then negative 4 over x is negative 4 over x. Let's separate it into two integrals. The antiderivative of x is x squared over 2. The antiderivative of 4 over x, which is 4 times 1 over x, that's negative 4 ln x, and then plus c. So that's the answer. 1/2 x squared minus ln x plus c. Now, if you want to, you can take this 4 and move it to the exponent position. So you could say it's 1/2 x squared minus ln x to the 4th power plus c. If you do that, then x to the 4th will always be positive. So you really don't need the absolute value anymore. And so this is it. What about this one? ln x squared over x dx. Try that. Well, let's make u equal to ln x. If we make u equal to x, du is going to be dx, and it's not going to do anything to the ln x squared. But if we make u equal to ln x, du is 1 over x dx. And if we solve for dx by multiplying both sides by x du is equal to dx. So u is ln x, so ln x squared is u squared. Dx is x du, and we can cancel the x variable. So now we have the antiderivative of u squared du. So if we add 1 to the exponent, 2 plus 1 is 3, and then divide by that result. Now all we need to do is replace u with ln x. So this is equal to 1/3 ln x to the 3rd power plus c. And so that is the answer. Now how about this one? X squared plus 7x plus 12 divided by x plus 3. Feel free to pause the video and try this. So how can we integrate this function? Sometimes you can use long division, but in this problem we can factor. Two numbers that multiply to 12 but add to 7 are 4 and 3. So the factor x squared plus 7x plus 12, it's going to be x plus 4 times x plus 3. And so we could cancel x plus 3. So all we need to do is find the antiderivative of x plus 4. The antiderivative of x is x squared over 2, and for 4, it's 4x, and then plus c. So that's it for that example. Now what about this one? X squared minus 3x plus 2 over x plus 1. How can we integrate this function? Well, we could factor x squared minus 3x plus 2. Two numbers that multiply to 2 but add to negative 3 are negative 1 and negative 2. But notice that we can't cancel anything. So doing this really won't help us. So in this example, we need to use long division. So let's divide x squared minus 3x plus 2 by x plus 1. So x squared divided by x is x. Let's put a negative sign and then multiply. X times x is x squared. X times 1 is x. Now let's subtract. X squared minus x squared is equal to 0. Negative 3x minus x is negative 4x. 2 minus nothing is simply 2, so we could just bring down the 2. And now let's divide. So negative 4x divided by x is negative 4, and then multiply. Negative 4 times x is negative 4x. Negative 4 times 1 is negative 4. So negative 4x minus negative 4x, they will cancel, they will add up to 0. 2 minus negative 4, which is 2 plus 4, that's equal to 6, which is the remainder. So this fraction is equivalent to what we have on top, x minus 4, plus the remainder over what you tried to divide it by, which is x plus 1. Now, this is a form in which we can integrate it. We can't integrate it in this form, so all we could do is change it to a form in which we can integrate the function. The antiderivative of x is x squared over 2. The antiderivative of negative 4 is negative 4x. And the antiderivative of 6 over x plus 1 is 6 ln x plus 1, and then plus c. Let's put this in an absolute value. So this is the answer. Here's another one that you can try. Find the antiderivative of x cubed minus 3x squared plus 5 over x minus 3. So once again, we're going to use long division. So let's not forget about the 0x. X cubed divided by x is x squared. And now let's add the negative sign. And then let's multiply. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. So what we have now is x cubed minus x cubed, which is 0. Negative 3x squared minus negative 3x squared, which is also 0. We can't do anything with the 0x, so all we can do is bring down the 5. And we can't divide 5 by x minus 3. So we have the solution. So right now, this fraction is equivalent to x squared plus 5 divided by x minus 3. And now let's integrate. The antiderivative of x squared is x cubed over 3. And the antiderivative of 5 over x minus 3 is 5. Natural log x minus 3. And then plus c. And that's it for this problem. So sometimes you need to use long division. Typically if the degree of the numerator is higher than the denominator, but not always though. What about this one? 2x over x minus 1 squared dx. Go ahead and integrate that function. So let's use u-substitution. Let's make u equal to x minus 1. du will equal dx. The derivative of x is 1, so it's 1 dx. Now, in this particular problem, we need to solve for x. So if we add 1 to both sides, using this equation, u plus 1 is equal to x. So now let's replace x with u plus 1. And let's replace x minus 1 with the u variable. And let's replace dx with du. So now let's distribute 2 to u plus 1. So we have 2u plus 2 divided by u squared. And at this point, we want to separate the fraction into two smaller fractions. So that's 2u over u squared plus 2 over u squared. Now let's simplify. 2u over u squared, we can cancel a u variable, so it's 2 over u. And for the other one, we can rewrite it as 2u to the minus 2. And now, let's go ahead and integrate what we have. The antiderivative of 2 over u is, that's going to be 2 ln u. And for the other one, we can use the power rule. If we add 1 to the exponent, negative 2 plus 1 is negative 1, and then divide by that result. So this is minus 2 over u if we bring it back to the bottom, so that the negative 1 exponent will be positive 1 plus c. And now keep in mind, we said that u is equal to x minus 1. So now we can replace it. So the answer is going to be 2 ln x minus 1 minus 2 over x minus 1 plus c. And so this is it. That is it for this problem. Here's the last problem. X squared minus 2 over x plus 1. Try that. So notice that the degree of the numerator is higher than that of the denominator. Let's use long division again. So it's going to be x squared plus 0x minus 2 on the inside. X squared divided by x is x. And then if we multiply, x times x is x squared. X times 1 is 1x. So now let's subtract. X squared minus x squared is 0. 0x minus 1x is negative x. And we can bring down to negative 2. So now we need to divide. Negative x divided by x is negative 1. Now let's put the negative sign and multiply. Negative 1 times x is negative x. Negative 1 times 1 is negative 1. And subtract. Negative x minus negative x is 0. Negative 2 minus negative 1, or negative 2 plus 1, is negative 1. So this expression is equal to what we have on top, x minus 1, plus negative 1 over what you try to divide it by, which is x plus 1. So now let's integrate the expression. The antiderivative of x is x squared over 2. The antiderivative of negative 1 is negative x. And the antiderivative of negative 1 over x plus 1 is negative ln x plus 1 and plus c. So that is the solution.